So
Yes, sir.
to invoke analysis toolpak, because usually on Excel you will not see data analysis toolpak. So you have to go to file, you go to file. So once you click on file, you go to more. Once you get to more, you click on options. Once you click on options, then you go to add in. You click on add in. Let's see. The next thing to do is to scroll down. You are going to see manage, and then you are going to see Excel add-in. Let me click on the drop down. Then I'll click on go. Once you click on go, a dialog options will appear showing analysis toolpak, analysis toolpak with VBA, that is Visual Basic, Euro Currency tool, Solver add-in. So our emphasis here is on analysis toolpak. We'll tick the box and then we'll click on OK. So once we click on OK, let's wait for it. So I haven't click on and go. If you look at my click on your data, you'll see something here, data analysis, where my cursor is. Data analysis. Can you see?
Mm.
Okay, so now that we have invoked it, so data analysis will be showing on our Excel. On a normal Excel, you will not see data analysis. You have to invoke it for you to be able to see data analysis. Okay, so now since we've invoked it and want to carry out data analysis, let's click on it. Waiting for it to open. Okay, the dialog box has appeared. A dialog box has appeared showing different data analysis that you can perform. We have number one here, ANOVA, that is analysis of variance, two-factor with replication. We have two-factor without replication. We have correlation. We have covariance. We have descriptive statistics. We have exponential smoothing. We have F-test, two sample for variance. Then we have Fourier analysis. We have histogram. We have moving average, random number generations, rank and percentile, regression, sampling. We have t-test, paired two sample for means. We have t-test, two sample assuming equal variances. We have t-test for two sample assuming unequal variances. And then we have z-test. So the first thing I want to do is to run for our descriptive statistics. So we click on descriptive statistics and click on OK. So once we do this, a dialog box will appear. A dialog box will appear. Then once it appears, it will ask us to impute the range. We have input range column. Then it will then ask you, how do you want the result to be arranged? Is it on the column or on the rows? And then you have a place to check if you actually selected the label in the first row. Then your output options. Do you want your results to appear on the same sheet where you select the range? Or you want it to be on a new worksheet or a new workbook entirely? You can do that. Then we also have summary statistics, confidence interval for mean, then K, that is the largest, and then the smallest. So let's go ahead. We are going to click on the input range, and then we'll select what we want to look at. Me, I'm selecting the first column. So I want to perform descriptive statistics with this. I've selected it. And then the question is, do I want the result to be on the column or on the row? Let's put it on rows. Then I will click. I also click that I have labels in the first column, and then I'll click on summary of statistics. Okay, I want the result to appear on a new worksheet. All right. Then intervals by 110, the confidence intervals level for mean, I can click. However, I can remain silent. Now click on OK. Let's see what's the problem. Sorry. Correct this and see. Let's see. Let me leave the first one. Okay. I'll check this now. Then I'll click on OK. Let's see. It's loading. Okay. Okay. Can you see my screen now? Can you see my screen?
Yes, I can.
Okay.
Yes, I can.
Okay, now you see it's showing us row 1, row 2, row 3. This is wrong because it's giving us results for what's his name now? Rows, that every rows is giving us. This one is wrong. And that is why you see that we have standard deviation is 0, mode is 0. Okay, so we have to do it again. At this point, I'm not going to say it should present the result on a row, but rather the result should be on column. So let's go ahead and correct this. So please take note of this so that when you are doing it, in
Mhm.
case you make mistake, because if you intentionally click on rows, you will not have your result, especially when you are working with descriptive. So now let's go ahead and correct this. Let it be on column. Then I want to correct the data set here. Let's see if I can correct this since I have label in it. Okay, I've selected. Then label in first row. Then let's click on OK and see. Okay, can you see my screen now?
Yes.
So you notice that what I did was I calculated for the first row. What do you have here? Let's make this okay. So the first item on that table was what are the barriers to your use of AI for research? So we have lack of awareness about AI tools. So for that item, the mean is this. The standard error is this, the median is this, the mode is 3, standard deviation is this, sample variance is this, kurtosis is this, skewness is this, the range is 3, minimum value in that column is 1, the maximum value is 4, the sum is 134, the count, we have 46 rows. So this analysis now is describing that column for us, that first items. Please, do you understand?
Yes.
Okay. So that is how to calculate for what's his name now? Descriptive. However, let's assume is in column, you want to present your result in rows. So it's just to then select this. Let's copy, then let's transpose it here. Then we'll click on transpose. Then once you click on transpose, you see we have a result. It's now on rows, right? We have mean, we have standard deviation, we have the median mode, standard Okay, standard error rather, that should be standard error. Let's make this big. Okay, okay. We have mean, standard error, median, mode, standard deviations, sample variance, kurtosis, skewness, range, minimum, maximum, sum, and count. So for this item, we have 46. That is the frequency there. That count, that is the frequency. Is that okay?
Yes.
Okay. So then if you like, you can edit it to fit into what you want. Let me cut this and put here. Then I can change this to frequency count. Frequency count. This frequency count. This is the main. So anyone you don't want, you can delete it. Then you perform the same thing for the next column. You perform for all of them. So you arrive at this. Then you can arrange your table. This is the first item. Let me copy this item here. So this is to be here then. Okay, then here it will be statement. I can adjust this. Okay, let's move this up. Let's move it up. Okay. Where is it? Okay, it's already this way. Okay, you can see what are the barriers to AI use. So the item is item one. You can put item two, follow like that, and then this is how you generate your descriptive table. So you successfully run for descriptive statistics. The next thing I would love to do is for other inferential statistics now. Now, unlike the one we did in the last class, where it only gives you the results for your t-test result, your chi-square value or this one value. When you run for descriptive here, and sorry, for inferential, it will give you full result. Let's go ahead now. Let's click on data, then click on data analysis, and then uh, let's perform ANOVA. So you see ANOVA single factor. Click on it and click on OK. Now we have it now. Now we've said that when you have ANOVA, it's one way ANOVA. That single factor means one way ANOVA, one independent and one dependent. Is that okay?
Yes.
Okay. So let's select
Yes. Yes.
let's select um let's select the the column. Let's assume the first one is the independent and the second one is the dependent. Let's assume that is how it is. Then label is in the first rows. So I'm going to check on it because the first row there is label. Then it said we should group it by column. Okay. Then the output range wants to be on a new worksheet. Then the alpha level, that is significance level, 0.05, right?
Mm.
Then we click on OK now. Let's see our result. Okay, can you see my screen?
Mm-hmm.
Okay, so now you see we have our results now. This is the summary table. That is for, let's assume this is the group one. This is the group two. Let me see if I can increase this so that it can show fully. Okay, okay, let's just okay, okay. Can we close this? Okay, it's closed. Bring it down a little bit. Okay, let me move this up. Okay, I believe you can see my screen. So we have the summary table showing us the frequency count, the sum, average, and variance. Then, because all these are all F tests, now look at this our ANOVA table between the group, within the group. That says DF, say is the degree of freedom is n minus 1. Then they have the ms, we have the f value, we have the p value, we have the f critical value. So this is your ANOVA thing. I am very sure you have seen something like this before.
Mm.
Okay, so this is how to run for your uh, one way ANOVA, one independent and one dependent variable. And we said that your dependent variable must be continuous.
Mm.
All right, so let's move on. Let's pick another one. We want to run for another inferential too. I guess it's making sense.
I'm trying to, but it's okay. I can.
Okay,
I'm trying to connect.
okay. Let's go to data. Let's click on data analysis. Now, for two-factor with replication, meaning that you repeated the experiment more than one time, maybe one, two, three, four, five, like that. So that is where you now select how many times was it repeated. You show the value. That is for two-way ANOVA with replication. You have to show. There's a place that they will ask you how many times was it repeated. You show it was repeated two times, type two or three times. You have to write it there. Once you put the value there, that is all. Then the system knows that this experiment was done repeatedly. Is that okay, please?
Yes.
So I'm not going to try ANOVA with replication. So
Yeah.
I'm going to move on to correlation. Okay.
Okay.
Click on correlation, then we click on OK. Then it asks us to impute our range. Usually when you carry out correlation is to check relationship between two variables. So let's select the two variables. I'm still going to use the first one and the second one I'll drag down. Okay, I'll move up now. Okay, selected. Then I'm going to click label in first row because I have label in the first row. Then I want the result to be on a new worksheet. Now click on OK. Now we have our result. Please, can you see my screen?
Yeah.
Okay. So, uh,
Mhm. How to start interpreting these results, Uncle? Mm.
okay. Let me see if I can interpret one for you. I'll interpret one for you. Okay. Okay. Can you see uh when you check the relationship between this one and this one? See, it is the same item, right?
Mhm.
This one and this one. Let me see if I can even enlarge it so that so okay. So you see that since it's the same thing, it's 1 1, right? So we are not using it.
Mm.
What we are using is this other one because if you check this one, it's also one. That is diagonal. So, but our value that we are using is this one, 0.455.
Mm.
Now, if you multiply this thing by 100, it's showing that this is 45.5%. So that there's relationship, a positive relationship, that is the direction, okay, between the first variable and the second variable. Not only that, the result also showed that the result is the strength is moderate, it's not weak and it's not strong because it's 45.5%. That is 46% approximately. Is that okay?
Yes.
Now let me go back to the first one we did. Where is even that descriptive? I guess you can interpret descriptive, right?
Mm.
Okay.
We just use the percentage. Mhm.
Yes, you can use frequency and percentage. Okay, the frequency count for this that is the lack of awareness is 46. Okay, the mean is 2 points so 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 and so. Then the standard deviation is 0.938. All right, so it's as simple as that. So if is a assuming is a scalar table where you have a reference, like you are measuring it, comparing it a particular scale, you can now compare your mean with the scale. If it is 4-point Likert scale is 2.5. If it is 5-point Likert scale is 3.0. Now, if you are using average weighted mean, it's different again. Average weighted mean, you must look for the average of your mean. Then whatever is your result, you'll be comparing it with the individual mean and you then take decision. Please, do you understand?
Yes.
Okay, let's check the ANOVA table. This is the ANOVA table. Now, if you look at the ANOVA table, basically, it's either you use this p value or you use this f value, you compare with f critical value. Once your f critical value is greater than if your f value rather is greater than f critical value, we usually say that it is significant. And if it's significant, your p value definitely will be significant. Because, like, if you look at, I want to quickly change this so I can see what I'm saying because it's not yet in a number. What is it now? Okay, now I've changed it to number. Now, if you look at it, this value, f value, is greater than f critical value, right? Right?
Yes, I can say yes.
Yes. So in 17,
Yeah.
17 is greater than 3.9 now. So now the
Mhm.
implication is there's statistic or there's significant effects.
Relation.
No, I know
Okay.
if I'm measuring effect or impact, okay, between
Okay.
so the two variables. So now, when we check this,
Mm.
the result shows that there is a relationship between within the two groups and the statistical difference or there's an effect between the independent variable and the dependent variable. Also, the p-value is less than 0.05. So,
Okay.
if the hypothesis was stated negative, that is no hypothesis, showing that there's no significance. Now the result is showing that there is significance. The implication is that hypothesis have to be rejected and the alternate hypothesis have to then stand. Is that okay? All
Yes.
right. So I guess we can continue now. So let's go back to our data analysis. We have done for one way ANOVA. We've done descriptive, we've done correlation, and then the next thing, let's see if we can do one more. Data and click on data analysis, and then let's check for uh, t-test, that is paired two sample for me. Click on it and then we'll click on OK. Now it asks us that we should select our variable one, the range, and then variable two, the range. Let's do for the first one. I'm going to select this now. I've selected it. And let's select the second one. I'm going to select this. Okay, selected. Let me click on label. Okay, now this is it. This is paired. It's on the 0.05. Then the output is on a new worksheet. Now the sample here is more than 30. We're supposed to use Z test where it's more than 30, but for the purpose of this class, I'll just still go ahead. So I'll click on OK now. Now we have our results. So for clarity's sake, I'm going to move this to let's put it here. Let me transpose it so I can see. Okay, it's better this way now. Although it's mixed up. Let me put it down. Okay, it's better this way. It's better this way because it will you have to present it in a horizontal. Yes, can you see my screen?
Yes.
Okay, okay. Okay, so if you look at this, we have the mean for the two. You can see at my variance. Then we have observation, they have 46, 46. The Pearson correlation, we have 0.455. This was what we got to when we ran for correlation, if you remember. Then hypothesis,
Mm.
hypothesized mean differences is 0. Degree of freedom is 45 because it's n minus 1. Then the t statistics is 5.64. The one t value is this, the t critical value is this. So you can decide to use one t if you want to use one t. If you are using two tail, then we will remove the one for one tail. Is that okay, please? So
Yes.
the
Yes.
this one, if it is two tail, it is this t statistics, it is significant. Okay, because from anything 2.5 and above for two tail statistics is significant for your t test. For one tail is from 1.0 that it is significant for your t test statistics. Yeah. Now, if you look at our, let me change this so I can see because that thing is 0.00 as well. Same thing with this.
Mm.
Okay, so if you look at this now, the interpretation, the result is showing that there is significant difference between variable 1 and variable 2. Okay, with the mean of, we state the mean and the mean of this. Is that okay? And the observation is 46. The Pearson correlation is 45%. Okay, the degree of freedom is 45. The results further shows that there is statistical difference, okay, between the two variable. Since the p or the t value is 0.05 is uh, less than 0.05. Is that okay? And the t statistics too
Yeah.
is also above 2.0 or is greater than or equal to 2.0. So meaning that there is statistical difference between the two variable. Please, do you understand?
Yes, sir.
Okay. All right. So we're going to stop here tonight. But okay, let me record my assignment. So for the assignment, let me let's go back. For the assignment, I want you to run an analysis to test for two-way ANOVA two-factor with replication and two-factor without replication. That is the first question. Then the second question is you because I've done for t-test paired. I've done that one. I want you to run for uh, z-test, two samples for me. Is that okay? That is three questions now. You see these ones that I ask you to do, I know that there are things, there are technicalities, so you must also do your research. Because when you want to run for your t-test, you must know the mean and is it the variance or so. So please, I want you to do that. Hmm?
I will first know the mean
And no, no,
before I run the
no,
test.
not t-test. That is z-test.
I will first know mean before I run the
They will
test.
ask you for the variance, sorry, the variance for the variable one, the variance for variable two. You must know the variance for the two variable because you enter it in a dialog box.
Mm. So how will I now do it?
You calculate your variance now. You calculate the variance.
Okay.
Yes. you get the variance for the two variables separately. The first variable you get the variance, the second variable you get the variance. Then of course you now enter it here. Is
Okay.
that okay?
I've heard.
Okay, because even the under this data analysis, okay, you have covariance. So we don't have this, but when we run for our t-test, we have a column for variance is 0.881159. Then second variable is 0.738164, right? So you get variance and then you put the value where it's supposed to be. So with that, you can then run for what is his name now? Z test. Run for Z test. And if even the one we did in the last class too, there's if you go to statistics, that is more function, that formula, more functions, statistical, you see var dot x, that is estimate variance based on sample, ignore logical values and testing the sample. Okay, then we have another, and then we have var, that is estimate variance based on a sample including logical values and tests. So you can just use va dot x so to get your variance. So, and if not, you can use your t-test. All right. So, and then you get your variance, and then use it to get your z test, as the case may be. So, I guess with that, you'll be able to. Thank you all for listening. Please do follow us, subscribe, and share for more exciting classes on data analysis.